Hey guys, welcome back. This lesson is actually really important. We're going to discuss the unit circle and then we're going to figure out some calculations. Also, we're going to be looking at the quadrants and seeing which trig functions are positive in which quadrants and which ones are negative. So let's start with the unit circle. The unit circle is so important, it's so useful. It actually helps us calculate really quickly. And so, what is this unit circle? What's so special about it? It just makes everything easier and neater. Okay, so here, a unit circle is a circle that has a radius of 1. So that's 1, 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 that's 1. Everywhere is 1. Okay? So first, I'm going to talk about a few of these points. Okay? So here I have the point 1, 0. Here I have the point 0, 1, negative 1, 0, and 0, 1. Okay, this doesn't make any sense. So let's get rid of this. And then here I'm going to have 0, negative 1. Great. So in a unit circle, x is going to be cosine theta and y is going to be sine theta. And let me show you why. This we said was a unit of 1. Let's talk about this angle that's made. Here we have y. Here we have x. So if we go x units over, y units up, and we land on the circle, we have a hypotenuse of 1. All we have to remember is SOHCAHTOA. SOHCAHTOA. Sine is going to be sine of the angle. Sine of the angle is going to be opposite over hypotenuse, which is just y. Cosine is going to be x over 1, which is just x because it's adjacent over 1. Okay? So sine is actually just the y, and cosine is just the x. Everything is neater and easier. So with that, look what we can figure out just from this beautiful unit circle. We're going to figure out all of these angles. These are very special and they're going to help us. So let's talk about sine. Remember, sine is y and cosine is x. Cosine x. That's how I remember it. X cosine. So what is the sine of 0? All we're going to do is we're going to go to 0 degrees, which is this, and we're going to go to the y value, and that's going to be 0. What is the sine of 90? Well, we're going to go to 90 degrees, and we're going to look at the y value. That's 1. What is the sine of 180? We're going to go to 180, and we're going to take a look at the y value, and that's 0. What is the sine of 270? That's going to be negative 1 because we're just taking the y value. And then 360 is going to be similar to 0. So that's it for that. Cosine 0, we're going to start going to the x value. So we go to 0 degrees and we go to the x value. So that's 1. We go to 90 degrees and we go to the x value. So that's 0. We go to 180. And we're going to take the x value. We go to 270 and we take the x value. 360, we take the x value. So just from the unit circle, I was able to figure out all of these degrees. Okay? So with that being said, we can also figure out, just from that, all students take calculus. What does that mean? Well, what that means is, think about it like this. Here's a unit circle, okay? Sine is y and cosine is x. In this quadrant, quadrant 1, what's positive? X and y, they're both positive, right? You go 1 over, 1 up, 5 over, 10 up. 17 over, 19 up. X and y is always positive, which means both sine and cosine. A stands for all. Sine and cosine are positive. But that also means tangent's positive, because I hope you remember that sine theta divided by cosine theta is tangent theta. So all trig functions are positive. Well, what if we go to the second quadrant? In the second quadrant, what does this mean? I go back x, up y. So look at the x, everyone. The x is negative. The y is positive. So that indicates only sine is positive. Okay? Think about this. If you go back x and down y, both sine and cosine are negative. And if you divide a negative divided by a negative, if you divide sine divided by cosine, you get tangent. And then here, everyone, if you go to the right and then down, you would have went x to the right, y down. So the only person who's positive is cosine, because x is positive, y is negative. All of this from the unit circle. It's incredible. So what we found from the unit circle is all trig functions are positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. I'm assuming everyone knows that sine divided by cosine is tangent. Okay? So I wrote here, and you guys could pause the video. Sine is positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. Cosine is positive in quadrant 1 and 4, and negative in the other two. So tangent is positive in quadrant 1 and 3, and negative in quadrant 2 and 4. Okay. This part here, I'm going to show you guys a trick on how to figure out this special right triangle. In geometry, you all learned about 30, 45, 60, right? So you learned about the 30, 60, 90 triangle and the 45, 45, 90 triangle. So here's how you can do it really quick. So watch this. You go like this. 1, 2, 3, 3, 2, 1. You divide everyone by 2, okay? And then you square root the numerators. So if you square root the numerators, think about square root of 1 is 1, so that's why I don't do that. Now you have every single special trig. Sine of 30 degrees, sine of 30 degrees, 1/2, sine of 60 degrees, rad 3 over 2, cosine of 45 degrees, rad 2 over 2. How do we get tangent? Well, to get tangent, you're going to have to divide sine divided by cosine. So you go 1/2 divided by rad 3 over 2. Guess what, everyone? The 2's cancel out. So basically, I'm going to have to erase this. Basically, you get 1 over rad 3. What I like to say, everyone, is you get the top divided by the top, because the bottoms cancel. So in this case, what's rad 2 divided by rad 2? What's the top divided by the top? 1. What's rad 3 divided by 1? Rad 3 over 1, which is rad 3. A lot of teachers make you guys rationalize the denominator. I sometimes do, I sometimes don't. Depends. And I'll tell you why in a second. We should talk about the reciprocals. Remember, a reciprocal does not change the sign, it just flips the numbers around. The reciprocal of sine is cosecant. The way that we abbreviate it is sine is like sin, cosecant is CSC. Cosine is COS. The reciprocal is secant, SEC. Tangent is tan. Cotangent is cotan. You can pronounce that as cotan, but you spell it as COT. Okay, so the reciprocals. So if you're asked for what is the cosecant of 30 degrees, and we'll do some practice on this. What you do is you say, I don't know, but I do know what the sine of 30 degrees is, 1/2. And all I have to do is flip it. That's all. So that's why you need to make sure that you have this, okay? So I did it again for you in this chart. You should pause it and fill it out for yourselves. Pause the video, fill it out for yourselves. 1, 2, 3, 3, 2, 1. Divide everybody by 2. Take the square root of everyone. Top over top, top over top, top over top. So if you want the cosecant of all this, you're going to flip 2 over 1, 2 over rad 2, 2 over rad 3. You can rationalize the denominators. If you want the reciprocal of cosine, you're going to do secant, and then you get 2 over rad 3, 2 over rad 2, and then 2. And then tangent is cotangent, and so the reciprocal is rad 3 over 1, and then 1, and then 1 over rad 3. So the reason why sometimes I don't like to do this is because if I rationalize this, I would have to re-rationalize it. Okay? So that's what we have to do there, and that's how we get the reciprocals. Let's try some practice problems. In which quadrant does the angle lie if sine is positive and tan is positive? So think about that for 1 second. Greater than 0 means positive. This is how I do these problems. I write all students take calculus. Sine is every single person is positive at home. Sorry, at home, which is S, and at the first quadrant. Everybody's positive at all, and they're home. So that's where sine is positive. Where is tangent positive? Everyone is positive in the first quadrant, and they're home. Where is there 2 marks or 2 checks or 2 highlighters? Quadrant 1. Let's try another one. All students take calculus. Sine is positive. Well, sine is positive here and here because everyone's positive in the first quadrant, and then at their home, which is S. Cosine is negative. Where's cosine negative? Think about it for a second. Everyone is positive here, and they're home. Therefore, they are negative at the other 2 locations. So what quadrant are we in? 2. Okay. Where is sine negative and tangent positive? Well, sine is positive here and here. Therefore, it's negative at the other 2 places. That's how I do it. Where is tangent positive? Here and here. Everybody's positive at all, and then everybody's positive at their letter. So you're in quadrant 3. What about cosine and tangent? They're both positive. Well, anytime 2 things are positive, you must be in quadrant 1. How do we do that? All students take calculus. Cosine is positive all, and it's home, C. And then tangent is positive all, and it's home, T. So you have that. And then here, so where is tangent negative? Well, tangent is negative. Well, tangent is positive here and here. That means it's going to be negative at the other 2 places. I would look at cosecant and remind yourself that it is the same thing as sine. Okay, C and S, they go together. So go to sine. Where is sine positive? Here and here. So you're in quadrant 2. Let's talk about this one here. Remind yourself that cotangent is just like tangent. So where is tangent positive? Here and here. Cosecant is the same thing as sine. Where is sine? Negative. Sine is negative here and here. Why? Because sine is positive here and here. So it's negative in the other two places. I would replace cotangent with tan. And once again, anytime you have two positives, you must be in quadrant 1. Okay, I think that's good for this video. Let me do this last one here, and then I'll show you how to do the exact value. All students take calculus. Cotangent is tangent. Where is tangent positive? Here and here. Where is sine negative? Sine is negative while sine is positive here and here. So it must be negative here and here. So I'm in quadrant 3. I'm going to pick this problem up in the next video where we will use that chart to help us.